Hi, this is a quick video response to a question in ROS Answers which states the following. Bumblebee XB3 Stereovision. So this user, essentially what he is asking is some tutorial or some example of how to use the Bumblebee XB3 Stereovision camera. So what I'm going to do is basically use a simulation of this Bumblebee Stereovision camera and show you more or less how this will work and how to make it do something useful, basically. So the first things first. So what I've done is I've used ROS Development Studio for this, and I have already a simulation running. So in this case is the Jackal robot simulation, and it has, here you have the Stereovision camera, and basically what it does is, if you go here for example, you have one image for right and left, essentially. Okay, so it's an RGB standard image. So to get this running, it's essentially you have to launch two things. You have to launch one thing, essentially. You have to start the Stereovision package. That's one thing, and the other one is to visualize it in an image, a disparity image that we're going to see in a second what it is. You have to launch a special node for that because RViz, for example, doesn't support it. So the steps, I'm going to close this. So the steps are the following. Let's close. Okay, so we have the Stereovision launch here. It's very, very simple. So we are using the package Stereovision processing, ROS package, and it's launching this binary, stereo image process. And the only thing that you have to do is remap the original topics that this node wants, which is left image raw, left image info, and the same thing for the right. So right image raw and right image info. This is basically what you need. So in our case, in this robot in particular, these are the names of those topics. So you just have to, in this side, put your version, your robot version topics. And here is the original one that this node will use. Okay? So that's it. So what it does here is, if we launch this, okay, we have different topics that are published now. So if we go here, let's have a look. So if we go here, ROS topic list, and what it does is publish all this new image, right color, compressed, monocompressed, and so on. These are subtopics that it needs and publishes in order to publish two main topics, which are the most important ones. One is ROS topic info disparity. So this is the image that we're going to see just in a moment, which is a combination of the two images, so the left and the right camera's images, and it publishes the disparity image. And this gives you an idea of the disparity between the two images, between the two cameras, and it gives you the three-dimensional information, let's say, the concept of the difference between those two images. This is one. the other one, which is really important, is now it publishes a point cloud also. So it publishes this point2, which is a standard point cloud 2, which we will see in RViz in just a second. So let's concentrate on this disparity topic. So if we go here, this is the other one, the launch file that we're going to launch to see this topic and see this disparity image. So here it's also very simple, is you need a type, so it's the package's image view and the type is stereo view. You just set it like this, so respond true on output screen, that's standard. And the only thing that you need, and it's a bit tricky, is how to remap. So what it does, this node, what it does is read and search for certain topics. So it searches for something called image, the rectified image that is published through the node that we launched here. So if we go here again, and we do a ROS topic list grep and then rect. So here you have loads of things, but basically we have this one, left image rectified and image the right image. So if we, for example, let's get this one, copy, and we ROS topic info, and we have, so this is published exactly by this node that we just launched here, the Stereovision node, and it's just the rectified image, and that's the one we need to do the disparity. That's the one it needs, this node here. The next thing is this stereo. So this is the namespace. In our case, if we go here again, so here we don't have any namespace. So the problem is that this node doesn't like not having anything here. So it needs to have something. So the thing you need to do here is put this / and then this is like empty namespace. If you had a namespace, so for example, if you had here, I don't know, my robot, blah, blah, then it would be my robot. Yeah? So we go here and we launch this launch. Okay. You see, it's subscribing to left image rect, so it's good. Right image, okay, and disparity image, so perfect. So once we have it, we just have to go here and it will appear. So sorry, let's go step by step. So here you open your graphical tools locally, it would just pop in your desktop. Okay, so here it's like plugging and having a screen, like plugging a screen to your server, and you don't see anything. That's because there's nothing to see. Okay, so let's publish something. Let's, for example, let's make a box appear. There we go. So now you see it's getting that disparity between one image and the other one. So essentially it's getting just the edges. Okay. If we turn it, for example, let's turn it a bit like that. Okay. So now it's seeing again the edges. Why? Because the disparity detects it exactly that. So let's spawn some more objects that I have here prepared. So we have a cylinder, just to see that it can detect with quite good fidelity, different shapes. There we go. And a sphere. There we go. Perfect. So now you can see that it's detecting that disparity image between the left and the right cameras. There we go. So this is really useful to see if the disparity is working correctly and the Stereovision is working correctly. Fantastic. So this is one application that you can do, and it's really, really useful. But the most useful data is the point cloud generated by the Stereovision node. So let's close this. We don't need it anymore. And then we're going to launch our viz, just like that. There we go. Now we open what I have already prepared. So there we go. There. Our viz and Stereovision. Okay. So now here we're just seeing what the robot is seeing, and there we go. So what we're seeing here is the point cloud. It's a standard point cloud, subscribed to the points too, and we're seeing there's the cylinder, the box, and the sphere. And that's quite it. So this data can be used for object detection and so on, and you're just using a stereo camera for this. So it's really interesting, and that's quite it. So I hope this was useful. I'll post all the code in the answer here, and hope you found this useful. Please subscribe to our channel if you like this content, to get more content about ROS and ROS courses related topics, and see you soon. Thank you.